Welcome to IT.Solution, your total network, system, firewall, and security partner.
All right, let's dive right into this explainer and demystify the unseen network layers that literally make our digital world function. Every single day, you use applications to communicate, browse the web, send emails, you name it. But there is a massive, invisible engine running constantly in the background to make all of that happen. So today, we're focusing squarely on ITN Module 15, which is all about the application layer.
It's something we completely take for granted, right? Every time you sit down, crack open a laptop to load a video, or just check your email on your phone, you are triggering an incredibly complex sequence of events. And it really raises this fascinating question. How do all these totally distinct devices made by completely different manufacturers know exactly how to talk to each other to deliver that web page instantly to your screen? Well, the answer lies in the protocols we're about to explore together.
To make sense of all this networking alphabet soup, we are going to structure our journey through 5 clear architectural sections. First, we'll meet the application layer, then dig into the presentation and session layers, compare client-server and P2P models, explore web and email protocols, and finally, look at some essential IP addressing services.
Okay, let's jump straight into Section 1, Meet the Application Layer, the interface between software and network.
Now, what's really interesting here is how the top 3 layers of the older, much more granular 7-layer OSI model on the left collapse perfectly into the single TCP/IP application layer on the right. This single layer serves as the absolute ultimate interface between the software applications running on your computer, like, say, Chrome or Safari, and the underlying network itself. It's essentially the gateway for your data to even enter the communication stack.
Moving right along to Section 2, Presentation and Session Layers, the translators and dispatchers.
Think of these layers like highly specialized departments in a massive corporate office. The presentation layer, that acts as your translator. It's in charge of formatting, compressing, and encrypting data so it's safe and totally compatible for whoever is receiving it. Meanwhile, the session layer acts as the dispatcher. It's busy creating, maintaining, and, if a connection happens to drop, restarting the dialogue between the source and destination applications.
To put that into perspective, without the presentation layer, your device would just receive a chaotic jumble of unreadable bits. There'd be no pictures, no movies. It guarantees that the raw data arriving on your screen is correctly recognized as, a joint photographic experts group image, a JPG, or a Matroska video file, which is an MKV. It provides the standardization that is absolutely crucial for your system to actually comprehend these specific file formats.
All right, Section 3, Client-server and P2P models, the architecture of interaction.
So when our devices interact, they generally follow one of 2 distinct rulebooks. In the traditional client-server model, you have a very clear division of labor. A client device requests information, and a dedicated heavy-lifting server responds to that request. On the flip side, the peer-to-peer, or P2P model, is way more democratic. 2 or more computers are connected, and they just share resources directly with each other without relying on a central server at all. Basically, every device can pull double duty as both a client and a server simultaneously.
Okay, I love this little relatable micro-narrative of Bob and Larry because it shows exactly how a client-server HTTP request works in the real world. In step 1, Bob opens his web browser. He's the client here, and his application asks for a web page. In step 2, Larry is our web server. Larry receives the request, checks his storage, and finds the specific file named home.htm. Finally, in step 3, Larry's server software packages that whole file up and shoots it back across the network to Bob, where Bob's browser renders it into a web page he can actually read.
Next up, Section 4, Web and Email Protocols, delivering the daily data.
Now, to securely retrieve those multimedia files from Larry, Bob relies on HTTP, Hypertext Transfer Protocol. Operating typically over TCP port 80, this is the foundational set of rules governing how web servers and web clients interact. Whether it's the text of a news article, a funny graphic, or a sound file, HTTP provides the uniform standard that allows that data exchange to happen seamlessly across the entire World Wide Web.
Now, email is kind of wild when you think about it. We usually think of emailing as just one single action, but it actually requires totally distinct protocols depending on the direction the mail is going. When you hit send on a message, your device uses SMTP, Simple Mail Transfer Protocol, to push that message out to the mail server. But when you open your app to check your inbox, your device is now acting as a client, pulling mail from a server. And for that, it relies on entirely different protocols like POP3 or IMAP.
And finally,
we arrive at Section 5, Essential IP Addressing Services, the network's foundation.
Here's the thing. Networks don't speak English. They don't understand words. They route data using numeric IP addresses. So without DNS acting as the Internet's giant phone book over port 53, you would have to memorize a random, long string of numbers for every single website you want to visit. No way, right? The domain name system bridges that gap. When you type cisco.com, DNS instantly queries its database, matches that human-friendly name to its required numeric IP address, and hands that number right back to your browser so the connection can happen.
And just imagine if network administrators had to manually type in an IP address every single time someone connected a new phone to the Wi-Fi. It would literally be chaos. That's exactly where DHCP comes in. It dynamically assigns your device an IP address in 4 lightning-fast steps. First, your device sends a DHCP discover message, just looking for a server. The server replies with a DHCP offer of an available IP address. Your device then sends a DHCP request to officially claim it, and the server finalizes the whole shebang with a DHCP ACK, an acknowledgement. And all of that happens in mere milliseconds.
So, as we wrap up this explainer, I really hope you never look at a simple web click the exact same way again. We've seen how the application layer formats the data, how DNS translates our words into addresses, how DHCP gets you onto the network in the first place, and how HTTP and email protocols deliver the actual content we rely on every day. It is, honestly, a beautifully synchronized digital symphony. So the next time you seamlessly load a web page, ask yourself, just how many hidden protocols flawlessly collaborated to make that happen? Thanks so much for joining me for this explainer, and keep exploring.
Thank you for watching. See you in the next episode.